All right, finally we get to the spicy stuff. Okay, the best. So here we go. Persevere. All right, so on page 531, number 47, I'm going to talk through with you. Okay, we're going to try and work it through together. Feel free if you want to pause the video in certain spots, but I really do want to work through this one with you. So aviation, the cruising speed of one model of commercial jet in still air is 530 miles per hour. Suppose that this jet is cruising directly east when it encounters an 80 mile per hour wind blowing 40 degrees south of west. Sketch the vectors for the velocities of the airplane and the wind. So this breaks it up into parts for you. So in part A, I'm going to have my coordinate plane, and I'm going to sketch those vectors for the airplane and the wind. So I'm going to sketch the airplane, and the airplane in still air is traveling directly east. So I'm going to go this way. And that's 530 miles per hour. And then the wind is 80 miles per hour, blowing 40 degrees south of west. So here is my west. I need to go south of that, south of west. So I'm going to go, what degree? 40 degrees. This way, 40 degrees. And this vector is 80 miles per hour. So there's part A. I've just sketched them. In part B, express both vectors from part A in ordered pair notation. So I'm going to go ahead and put this as A and B. So I'm going to have an ordered pair for this one here. And where is it going to be at? With the arrows, it's going to be at 530, 0, because it's right there on the x-axis. This one takes a little more work. This one, I'm going to have to form my 90-degree right triangle, and I'm going to have to make use of some trigonometry to figure out my x-coordinate and my y-coordinate. So I'm going to use some trig as in, how would I get x? Which trig function? I'm going to make use of the cosine of 40 degrees equals adjacent over the hypotenuse. And then I'm also going to solve sine of 40 equals opposite over the hypotenuse. And I'm going to solve for both of those so I can get both those ordered pairs. So I'm going to go ahead and calculate it. You can too here. $40 cosine, so there's cosine of 40, and I need to take that and multiply it by 80. And there is my x coordinate. Keeping in mind that I went to the left, so I'm going to make that a negative 61.3. And then if I actually calculate and do the right calculations there for sine of 40 times 80, and I did go down to get there, so it should be a negative number. That's the only thing you have to keep in mind. And I did end up writing this wrong. Maybe you did too. I'm not going to use parentheses because I'm representing a vector, so I'm going to use those arrowheads. Okay, part C, find the sum of the vectors from part B. So I need to take my two ordered pairs and find the resultant vector. So I'm going to have my 530 added to my negative 61.3. And in part C, my resultant vector, 530 plus negative 61.3, is 468.7. And then I'm going to add 0 and negative 51.4, and that one's nice, negative 51.4. So there's my resultant vector. And then in part D, find the magnitude and direction of the vector from part C. So I'm going to take this, I'm just going to plot it approximately where I think it is. I'd go this direction, 468.7, and then I'm going down 51.4. So here is my vector, that one there. And I've actually already formed a 90-degree triangle. And then They want to know the, what was it, magnitude of this vector. So I need to know the size of this vector. So I have my right triangle. How am I going to get it? I already have two sides, so I can make use of the Pythagorean theorem. 468.7 squared plus 51.4 squared equals that hypotenuse squared, and then I'm going to square root that. So I'm going to go ahead and do that. Hopefully you are too working with me here. So I have 468.7 squared plus 51.4 squared, and I just kept it positive because if I squared it, it's going to become positive. And then I'm going to square root that. And round it to the 10th, 471.5 is the magnitude of my vector. So that's miles per hour, because that was the unit before. And then the direction. So this would be my direction here. I need a degree on this. I know it's going to be something of something. Started out at east, and I went south of east. By how much? And the reason I don't use this side is because I don't have my numbers on the right triangle for that. I have them on this side, so I'm using this angle. So which trig function am I going to use? I'm going to make use of these numbers, so I'm going to use the tangent. You could technically use any of them. Or opposite over the adjacent. So I'm going to have 51.4 divided by that number of 468, right? 468.7. And then I'm going to do the inverse tan of that. And so I end up at, rounded to the nearest tenth, 6.3 degrees. So I'm going to say 6.3 degrees south of east with a magnitude of 471.5 miles per hour. So there is a spicier example. So in number 48, you're going to try and persevere through that about a fishing boat navigating themselves. And you have, I'll just start it off, you have your drawing. Actually, I shouldn't. You go ahead and try and figure it out. Pause the video, work it through, and then when you unpause, I'll actually work through the entire problem. Okay? So I'm going to start in right now. A fishing boat leaves its home port and travels 150 miles directly east. Oh, it left home. Uh-oh, bye-bye. 150 miles east. It then changes course and travels 40 miles due north. From here, it goes 40 miles due north. Cha-ching, 90 degrees north. In what direction should the boat head to return to its home port? And home was at the origin. You might say, well, just turn and go that way. No, we have to be exact with what angle this is in which they would turn. I need an angle number. So how could I do it? I could use trig. I have this and this based off that reference angle, so I'm going to use tangent of that angle equals opposite over adjacent. So I'm going to take 150 divided by 40, inverse tan, and I'm at 75.1, I would say. Because they want to get home. You want to be exact. So 75.1 degrees, and now I need a direction. Blah, blah. So now if I pretend that this is the origin now, this right here, if I pretend that's the origin, where am I going? This angle? Well, I could originally start out at the base of south and go which way? I would end up going...
Jackson Smith, please come to the office.
I would end up going west of south, right here. Okay? So I could say 75.1 degrees west of south. Cha-ching. All right. Oh, wait, that was just part A. Part B. If the boat averages 23 miles per hour, how long will the return trip take? Okay, so we need to know the magnitude of this. What's the length of this? And then I can bring in the information of traveling 23 miles per hour. How can I find that length? Well, I have both legs, so I can use the Pythagorean theorem. So I'm going to take 40 squared plus, what was the other one now? 150 squared, and then square root it. So I'm at about 155.2 for this, 155.2 miles. And they're going the speed of 23 miles per hour. So what would I do with these two numbers? Well, if every hour they're going 23 miles, I'm going to take 155.2 divided by 23 to see how many hours it's going to take them. Oh my gosh, I'm so close. Divided by 23. And it's going to take them about, rounded to the 10th, 6.7 hours. 6. Wow, that's a long time to be on a boat to get home. But you know what? Then they get home. And they get a really nice meal, right? Way to go, you guys. You made it. You made it through the vectors. We made it through some spicier problems. Although you could try something even spicier on page 532, number 50. But you're good with this. Okay? Need to rewatch some stuff. Thank you.